For this problem, we're given a truss. We're given a truss that has loading at 3 points, A, B, and D, of 135 kilonewtons each. And we're asked to solve for the force in members BD and DE. So we'll look at this, we'll break it apart. We're going to look at the truss as it is from points A, B, E, and C. So we're breaking it into a component. I'm going to start with my free body diagram. Let's see. Okay. Okay, so we have point A, point B, C, and E. And our loading is 135 kilonewtons in the x direction at A and at B. We have our distance, 4.5 meters across and 2.4 meters vertically between A and B and D. So knowing this, let's take a look at what our reactions would be. We know that in EG, we'll have a force. So let's draw that in, F, EG. And then we know that in DE, we'll also have a force. All right, and then we know in BD, we'll have a force. So knowing this, let's start with a equilibrium equation. We're going to set the sum of the moments about point E to be 0. And so we know about point E, we'll have a contribution from our 135 kilonewtons. And we know that that is this 135 kilonewtons applied at A is 2.4 meters above B, and B is 2.4 meters above E. So we have a total vertical distance of 4.8 meters. We know that it is a negative contribution because it would create a clockwise moment. And then also we have the 135 kilonewtons applied at B. And we know B is 2.4 meters above E. Now, we also know that we have the force from BD over here, which is 4.5 meters away, and this downward force would actually create a counterclockwise moment, so that will be positive. So we have plus a contribution from FBD times the distance, 4.5. So we have 4.5 meters. And when we solve for this, we get F of BD will equal the 135 kilonewtons times 4.8 meters plus 135 kilonewtons, it's 2.4 meters, divided by 4.5 meters. We know FBD will equal 648 kilonewton meters plus 324 kilonewton meters divided by 4.5. FB sub D equals positive 216 kilonewtons. So B sub D, positive 216 kilonewtons. Okay, so we've solved for FB sub D. Now let's look at solving for f d sub e. And to do that, to solve for f d sub e, let's take the sum of the moment, not sum of the forces in the x direction. So sum of forces in the x direction for this component is going to equal 0. And to factor in everything that applies, we have 135 kilonewtons applied at A, 135 kilonewtons applied at B, and then we have the force dE. And we know, well, FDE equals 0. So FDE equals 270 newtons, kilonewtons rather. Okay. All right, so we've solved for F B sub D and F D sub E, 270 kilonewtons, and remember DE, 216 kilonewtons in BD, and 270 rather in DE.